Okay, I will give you a presentation about this digital climate atlas of Serbia. It's atlas and it's digital. And next slide. Okay, it's online tool. It's interactive and it's for you. It's available to use anytime you like to understand how the climate was changed in Serbia for the last about 70 years, and also to see the projections of the future, to see how the climate is going to look like in the future. Okay, and this is the landing page to the atlas. So you have these four main, let's say, data sets, and then you have here some menus in which you can pick up what you want. So there is a 4 variables and 22 climate indexes. When I said variables, it's temperature and precipitation and things like that. But the climate indexes are derived variables from that essential, as it call it, like a number of summer days. So the summer days is the day when the temperature is above 25 degrees. So you have index, which is measure how much of summer days you have during 1 year. So you can have time series how this number is changed into the future. So in total, you have like a 26 different numbers that you can explore, and you can explore numbers for the whole of Serbia, for these regions that you can see now, for municipalities, and for single points on the map. So you can choose your point and see how this variable is changing in that point. There is the time period that is covered is from 1950 to 2100, and there is 2 scenarios of the future. So you have scenario in which people doing zero about the climate change, continuing to emit CO2 into the future, and there is another scenario that we call it mitigation scenario. So it is scenario in which people in one moment stops to emit CO2 and stabilize climate system. There is different seasons like summer, spring, etc. And there is a 4 level of spatial analysis. So as I told you, you can calculate something over the whole territory, then over the region, over the municipality, and over a point of interest. And also, if you click on the map, you can see this time series of variable that you want. This variable here is growing season. It's part of the year when plants are active on surface. And all that you can see on the atlas, you can download as a figure, or you can download it as a data. So all data is free available to be downloaded and use it without any kind of registration and any kind of verification for what purpose you're going to use the data, etc. So all data is open to be used by anyone who is interested to use the data. The atlas is developed under the project with a really long name. It's funded by Green Climate Fund and implemented by UNDP in Serbia, and it's developed by Faculty of Physics, on which I work as a professor, and the Neopix company from Niš, and it's hosted on this web address atlasklimaeco.gov.rs. It's hosted by Ministry of Environmental Protection. So why we first created this atlas? The main idea was to support adaptation process to climate change in Serbia. So if you build a bridge in some city, you want to build a bridge which is going to be resilient to the future floods, not only the current floods, because we know that we have this positive trend of extreme precipitation. We have stronger and stronger precipitation for the last 70 years, and we're going to have stronger precipitation in the future. So if you want to build a bridge in some city, you don't want to build a bridge which is resilient to current precipitation and current floods, but you want to build a bridge that's going to be resilient to the future precipitation change and future floods. So if you sit in that municipality, you want to have the data how the precipitation is going to change into the future, and to create your spatial plans, bridges, everything to be more resilient. And it is called adaptation to climate change. So how you're going to adapt to face lower level of problems into the future. So the main idea is to have the data that is available for everybody who needs to plan the future and to make that future more safer in terms of climate change. and that was the main idea why the ministry built this atlas. But we also try to implement other ideas that can be, let's say, that we expand these potential beneficiaries of this atlas. For example, you can use atlas for education. You can see how the climate is changing in current moment and how it's going to change into the future. So it can be interesting to educate people about the climate change. Then for professional decision makers or companies that can consult somebody what to do into the future. So you can create, let's say, small engineering company who can advise agriculture producers how the climate is going to change in the future and how they can change their practices in terms of this agricultural calendar during the year, etc. And you can sell, of course, that information, but the background information is freely available, and you can use that information from this atlas. And also the atlas can be used for this, which is public communication, because climate change is really huge problem, and you really need to have a lot of people on board to, let's say, solve it. And the public communication about the climate is very important. The people need to know that something is happening, is going to be worse, and that there is a chance that we can stop that in the future if we act on time. Also, there is other ideas behind the atlas. Some of them are also presented. We want it to be simple, so you have a lot of other atlases, digital atlases online, like IPCC atlas, which is global, and then you have this Copernicus atlas, but both of them are more designed for professionals or semi-professionals. So you need to know something about the climate models, climate change, etc., to be comfort with that. But we wanted to have tool for which you don't need so much background knowledge to navigate through the data, and also we wanted to have all the data available to all people, but also for professionals. We made a special page on which you can download the whole data set and then operate over the data. So you don't need to browse through the atlas and to change pages and variables, but you can go to one page, download everything, and then you can process what you like. So in that sense, on the atlas you have limited number of options, but we think that all options are there because we want to clearly communicate this climate message. You will see at the end what is the climate message for Serbia. So the atlas is designed that somebody who uses atlas will easily pick up this main message for Serbia. The background data is produced or downloaded from Copernicus, let's say, system, and observed data relies on this EOPS grid climatology and the projections coming from this Eurocortex data. So we didn't produce any of data on the atlas, but just customize that data for Serbia. And the reason why we do that, because if you want to do what we done here, you need to download about 60 terabytes of data, and the total volume for the atlas is half of terabyte. So if you want to pick up one point over Serbia and calculate how extreme precipitations is going to change in the future, probably you will not need to download 60 terabytes of data, but probably you will need to download something like a few terabytes of data, and then you will have just one figure how the precipitation is going to change. It will be very small. It will be like a kilobytes. So the idea is that we use this huge volume of data that we have in the background, and then we customize the data for the users in Serbia, so we don't need to reprocess every time that big volume of data to have local information. And that's the point when we talk about this minimum sustainable data sets. So we try to reduce the amount of information that is really needed over the Serbia. And when we done that for once in a time, then everybody can use that minimum data set and to reprocess it many times more. So we done a job for many other people not to do, and just to use our results. And to demonstrate you this kind of how to call it paradox in world of climatology, I will give you a story about this figure. Okay, this is the main figure for global negotiation, political negotiation about the climate change. And this figure is a figure about the global temperature of Earth, mean global temperature. The black line is historical temperature from the 1950s up to now. So the black line is history. And these colored lines are future scenarios, how much the Earth is going to warm up into the future. Okay, so one of the scenarios said you can expect 1 degree more warmer world by the end of this century, and another scenario tell you it can be like a 5 degrees warmer. Okay, and this planet which is 5 degrees warmer, it's almost uninhabitable. Okay, it's really different planet. It's a planet with a lot of problems. Okay, and this planet here also has a problems, but the problems that can be controlled. Let's say we can adapt to this, and it's really hard to adapt to this here. So when you have a global negotiation, what the all nations around the world is going to do about the climate change, they'll look in this figure here and decide which future they're going to pick up. Are we going to pick up this future or this future? Okay. And officially the world pick up this future, but in real life we pick up something between. Okay. But this is the main figure how we negotiate about the future of the Earth. And this figure, the size of the figure is about 200 kilobytes. But the data behind this figure is 3 petabytes. So climatologists need to produce like a 3 petabytes of data to give you this figure, and then you should negotiate about this figure. Okay. So it's really interesting how much of information we really produce to come to the moment in which we're going to decide what we're going to do using just simple colored lines. Okay. And one of the idea in the climatology is to try to understand how to produce as much as possible small volumes and to have reliable information on which we're going to negotiate. Because currently we really use a huge amount of processing time and silos of hard drives, etc. These big climate centers have these super big supercomputers of hundreds of thousands processors, etc., to produce all this information. So in our story about the climate atlas, it's not story about this figure, but it's story how you try to reduce your volume size of the data to the data set, which can be useful for a lot of people, and in that sense to keep information as smaller as possible in terms of kilobytes, megabytes, etc. As I told you, there is 4 levels of this data analysis, and that's the point again about the data volume. So if somebody wants to pick up grid point here, if he starts from the beginning, he will download like 10 terabytes of data, and he will process all that data and get the information here. And if everybody, municipality in Serbia do the same things, then the Serbia will download like 200 times of 6 terabytes of data. And because we don't want to that happened, we downloaded 60 terabytes of data for the whole Serbia, prepared data for each municipality, and from that moment, each municipality will have information for themselves, and that information can be just one Excel file with 2 columns with temperature and date or year or something. There is also the page on which you can learn what is the climate indexes, what are scenarios, what are climate models, and there is also a page with the file names, because we decide to have this kind of file naming convention. So when you download the file, you know what is inside the file without any metadata about the file. The files itself has a metadata inside the file because the format of the file is with the metadata, with the header. The format is netcdf, but also the name of file is already metadata. So if you learn how the letters and acronyms are put it in the name, you easily understand what what is inside the file. And this is also one interesting thing, because there is a lot of maps with the colors. We use these color bars which are colorblind safe, because some people are not capable to see different shades of same color. But you can choose color in that way that everybody can see all shades. And if you learn what are shades and how are defined, they are put it, you can find it in the metadata of the file. So if you scan this netcdv file, you will see each color for that map, what is the color of that shades. And this is the main message. Who is interested in future climate is Serbia. I told you one of the ideas was that Atlas give you the main message how the future climate will look like in Serbia. We had a really hot summer this year, and if you think it is hot, it's not hot, it's going to be hotter. So looking into the heat waves, we can expect increase in heat waves in terms of frequency and intensity of heat waves. Here we can also expect increase in temperature. We can expect a decrease in summer precipitation. We also had a strong drought this year, and this trend of the summer droughts will extend into the future. So in the future, we can expect more droughts like this one and stronger ones. But on the other side, we can expect more extreme precipitation in the future. So we also should think about the floods, not only the droughts, and it's complicated. And here is the frequency of drought. This is the frequency of the amount of precipitation. This is the frequency of drought. And it's interesting that on annual level, we will have more or less the same amount of precipitation. The total amount of precipitation will not change into the future, but what's going to happen, you will have like a long periods of dry weather, and then in a short time period, you will have all precipitation that you skipped in past few months. So you will have drought, and then you will have a risk of flooding. Okay, and that's the story about Digital Climate Atlas. Probably it's a new topic for you, so it will be great to have questions from your side to understand how you see this tool and this job.